Welcome to The Explainer. You hear people talk about the cloud all the time, right? Well, today we're actually going to look under it. We're going to get into the actual physical hardware, the boxes, the cards, and the wires that really connect you to the internet. So let me just start with a question. You click on a link and poof, a page just appears. But have you ever really stopped to think about the magic that's happening behind the screen in that split second? I mean, what journey does your click actually take?
Well, the answer isn't some single magic box. It's actually a whole team of unseen specialized devices, and they're all working together. Each one has a really specific job to do. So let's meet the players, starting with the one that's closest to you.
We're going to start with the layer that's right there with you, the hardware that literally lives inside the machine you're using to watch this right now.
Okay, first up is the Network Interface Card, or what we call a NIC. The best way to think of this is like a passport for your device. It's the piece of hardware that allows your computer to speak the language of the local network. Without it, you're not getting in.
And here's the thing. Every single device that connects to a network needs one of these. Your desktop computer probably has that physical port for an Ethernet cable. That's a wired NIC. Your laptop or your phone, they use a wireless NIC to grab that Wi-Fi signal. It's the same job, just, no cable. All right, let's take one step out from your computer. Now we're looking at those familiar boxes, the ones with the blinking lights in your home or your office. This is the hardware that manages your local network.
First, the internet has to actually get into your house, and that is the modem's job. It's basically a translator. It takes the signal from your internet provider's cable or phone line and converts it into a digital signal that your devices can actually understand.
So once that signal is inside, the router takes over as the traffic cop. It takes that single internet connection and manages it for all of your different devices. It uses their IP addresses to make sure that, say, a video stream goes to your TV while an email goes to your laptop.
And how does that all become wireless? Well, that's the access point. It takes the wire connection from the router and broadcasts it as a Wi-Fi signal. Now, a lot of the time, these three things are all crammed into one box from your provider, but they're still three totally distinct jobs.
So let's just put that all together for a second. A request starts at your device's NIC, it jumps onto the Wi-Fi signal from the access point, then it gets directed by the router, and finally it's translated by the modem to get sent out to the big, wide internet. And all of that happens in less than a second.
Now, if you have a wired network, the old school way to connect everything was with a hub. And you can think of a hub as just a loudmouth in a crowded room. It just shouts any data it receives to every single device connected to it. It's super noisy and really inefficient.
This is exactly why we use a switch now. A switch is so much smarter. It's like a high-tech mailroom sorter. It learns the specific address of each device that's plugged into it and sends data only to the device that's supposed to get it. No more shouting.
So, yeah, think of it this way. A hub is a loudspeaker, creating a ton of unnecessary noise. A switch is like a private mail carrier making a direct delivery. That efficiency is why any modern network with more than a couple of devices is going to rely on switches to keep things moving fast.
So what if your signal is just too weak to get to the other side of the building? Well, that's where a repeater comes in. It's just a signal booster. It listens for that weak signal, cleans it up, and then blasts it out again at full strength. It's perfect for big spaces, like a warehouse where you need Wi-Fi to cover a lot of ground.
Okay, so we figured out how to build a local network, but how do you connect different, completely separate networks together? Well, that's going to require another set of specialized hardware.
First, there's the bridge. And it does, well, exactly what it sounds like. It connects two similar networks. So think of a school campus with a network in the science building and another one over in the library. A bridge connects them, but it's smart. It filters the traffic so only the data that really needs to cross between them actually gets through.
But what if the networks speak completely different languages? They use different rules or protocols, as we call them. For that, you need a gateway. This thing is the ultimate translator. A perfect example is the company's private internal network trying to talk to the public internet. A gateway sits right between them, translating everything to make it all work. Okay, let's zoom out one last time and look at the real heavy-duty devices. These are the guardians that manage and protect the massive, massive scale networks for the businesses and services we use every single day.
The first guardian you need to know about is the firewall. Its job is to be the network's security guard. It stands right at the edge of the network, inspecting all the traffic based on a very strict set of rules, and it blocks anything that looks suspicious. Its whole goal is to protect sensitive data from outside threats.
And our second guardian is the load balancer.
Ever wondered how a huge website, say an e-commerce site, doesn't just completely crash during a massive sale? That's the load balancer's job. It's an expert traffic manager, and it distributes all of those visitor requests across a whole fleet of servers so no single one gets overloaded.
So there are your guardians. You've got the firewall, acting as the security guard, the load balancer as the traffic manager, and the gateway as the universal translator. Every one of them plays an absolutely critical role in keeping the large-scale internet running smoothly and securely.
So you see, in the end, the internet really isn't magic. It's more like this beautifully complex digital symphony. You've got everything from the tiny little card in your laptop all the way up to a massive corporate firewall. And each one is an instrument playing its part to bring the digital world to your screen in an instant.
And that really just leaves us with one final thought. As our cars, our homes, and our cities become more and more connected, what new instruments is this digital symphony going to need? What new devices are we going to have to invent to keep it all running smoothly and securely?